Hi, hello everyone. Thanks for coming before the class time start. So today is going to be our last career readiness talk. And so it's a very special one because today we have a very special guest who is not a Stony Brook BME alumni, but someone who actually helped us train a lot of our students in biomedical engineering. And the evidence are actually sitting in the front. And so you guys will get to see our alumni and actually current students who have worked with Dr. Lebov. And so he will tell you a little bit more about his background and how he goes from a medical doctor, a surgeon, and he also does something to invent things that he can use. And I think the name of your company is called Tools for Surgery. So the name is very nicely crafted, very original, and it's very, very well described what he's doing, but he will tell you a little bit more about his history and how he got to where he is. I think we are going to plan to do something like this today. We would like you guys to meet the student who have worked with Dr. Lebov, and also you can get to ask some questions both for him and also the student who have worked with him before. So yeah, without further ado, let's welcome Dr. Lebov.
Thank you, Dr. Chan. Thank you for inviting me. And it's nice to see all my friends here again. And thank you for allowing me to bring my daughter and my wife who wanted to come and see what the heck I've been doing all this time. They kind of think all I do is just lie around and scroll on Facebook, but maybe they'll get a little different impression now. Let's see if we can. I want to thank Joy and I'm sorry, I blew it. Vinaya for coming down before and helping us get things set up. I am a colon and rectal surgeon and a general surgeon. I'm a member of the American, I'm a fellow of the American College of Surgeons and a fellow of the American Society of Colorectal Surgeons. In the last couple of years, have limited my practice just to anal rectal surgery, office proctology, and colonoscopy. So I'm no longer doing the big cases. So I'm really more of a proctologist and a colorectal surgeon these days. Here we go. Our society, the Society of Colorectal Surgeons, started out in 1899 as the American Proctology Society, but in 1973 they changed their name to the American Society of Colorectal Surgeons, and in the 70s also the board changed its name to reflect the bigger types of practices that we're involved with. But these days I consider myself more of a proctologist. I have a practice in East Setauket, but I also have a company called Tools for Surgery, which is a company where where we manufacture devices for general, bariatric, and colon and rectal surgery. Our tagline is all surgeons are inventors, and I really feel that way because every operation is different, and in every operation you have to, in a way, invent your way of doing things. I have 10 patents to my name, and these are some of the instruments that are patented that we sell on our that we market in our company. Dr. Chan asked me to come by and explain why I became an inventor, and that's not the usual question I get. This is the usual question I get, maybe at least one time a week. Usually when the patient is going on the table and just like this and look at me in a crazy way and ask me this. It didn't happen this way. I did not wake up as a kid one day and decide I want to be a proctologist. And I didn't wake up as a kid either saying I want to be an inventor. But I did, I think, start on this direction when I was probably in 6th grade when I took a mechanical engineering, mechanical drawing class. It was really these tools that I used to help me even when I started out in my effort to make new things. These are the tools that I was trained with in 6th grade, and I was wondering whether you guys, as budding engineers, even recognize these tools. I don't have a pointer on here, but does anybody, shout out if you will, does anybody know what number 1 is called? Tom, what's that? What's that tool that there, number 1? What's that called?
It might be a ruler.
A ruler, no. That's interesting that all of these students right here, and probably many of you, yes, what is that?
It's a T-square.
Oh, beautiful. There's somebody we know.
T-square.
What's your name, sir?
He's gonna get the
Yeah, you can come work with me next year. It's interesting that, well, many of you who are probably very proficient in CAD drawing aren't even familiar with these devices, which used to be the bread and butter stuff, the tools of mechanical engineers. What was your name again?
Krashiv.
Krashiv, do you know what number 2 is called?
No.
It's
Anybody? Shout it out for me.
Some kind of triangle.
It's a right angle. Number 3, anybody?
Triangle.
I'm sure you know number 3. Number 3, what's that?
compass.
Yeah, sure, that's a compass. Number 4, what's that we use every day?
Oh, that's ink. Ink.
Huh?
Ink.
Very good. Are you an engineer?
Well, I.
Yes, but what kind of ink is it, dear?
What? Oh, yeah. That's
What kind of ink is it? It's anybody? Anybody?
Indelible.
This is India ink, of course.
India
You know why it's called India ink? Anybody?
It's from India.
Beautiful. Yeah. You come see me after class. You know.
All right.
Okay. Yeah, yes, it's from India. Who's buried in Grand's tomb? You're very good at that kind of work.
Yeah.
Number 5. What's number 5? Surely everybody knows this. Number 5. Shout it out.
Protractor.
Protractor. Number 6. Anybody, what is this instrument and why did we use it? We used it every drawing we did. At least I used it every drawing I did. Tom?
Maybe to like get rid of the eraser shade.
Yes, I had to erase things most of the time because I wasn't happy with it. So that's what it's called a what? A brush. Very good. And Santa, what's number 7? 7. Now what's number 7? Who knows? Come on. These are basic instruments of the engineers that preceded you.
Yeah.
Yes, who said that? Oh, beautiful. You're doing very well today. Yeah.
Marty, what is it?
It's called a French curve.
Oh.
It's a French curve.
Oh.
It's what we use to connect between and to draw curved surfaces.
Okay.
This is me in 1966. This is at the Fairleigh Dickinson, North Jersey Science Fair, and we did a project on centrifugal force. I say we because I had a little help. I did, or we did, win first prize here, and although I was a little bit proud of that, I was honestly a little bit uncomfortable. It's about 60 years later now, and I want to give you a confession. The confession is that my dad did really most of this work, and
Love it.
it made me a little bit uncomfortable. It made me a little bit, I don't know, feel that I didn't accomplish much, you know. So I said next year I'm going to do my own project. I'm going to do it entirely by myself. So this was talking about 1967 now. I think I was in 9th grade. And a big talk in the tech community was about lasers at the time. The laser was invented in 1960 by a guy named Theodore Maiman out in California working for used aircraft. And it was a ruby laser. And this is a picture of the first laser ever made. And this is the first newspaper article headline because they had this great new invention. They didn't know what they were going to do with it. And this was one of the things they dreamt of. So I had in my head that I was going to maybe make a ruby laser. Of course, that was way beyond my capability. But I still had an idea about the design of the laser, and this idea came from the principle of an ellipse where you have two foci. Does this have any, let me see if it, yeah.
Along the line from focus always gets reflected to the other focus, no matter where it hits the table.
So the concept was this, to create a elliptical housing, a cylindrical elliptical housing for the device so that the xenon flash was at the one focus, along one focus, and the ruby element that in which the coherent light developed was at the second focus. And by having this arrangement, all of the energy output from the xenon light bulb would hit the ruby rod and therefore increase the efficiency of this device. That was really my first ever invention, and this illustrates that concept. This was back in 1967, and we didn't have at the time the ability really to manufacture elliptical cylinders or elliptical cavities within metal. So I thought that one way we could do this was by approximating it by having flat segmental slabs to approximate the ellipse. So my invention or my design was both the elliptical cavity and the faceted approach to it, and I used my 6th grade drawing skills in order to draw that out, so I presented that at my next science fair in 1967, I believe it was. You can see that drawing in the picture, we didn't win first prize. We didn't win any prize, but I did it myself, so I was kind of happy with it. Now, it wasn't until 2 days ago when I was kind of back then we didn't have the access to information at our fingertips like you did today. There would really be no way for me as a kid to know what was going on currently at the time in the field of laser development. Now I know that the technology was exploding in those years, and now when I went to look at some current articles on websites, I found that indeed this concept of elliptical housing was used and was actually used quite frequently. with lasers. That explosion of laser technology went on to influence medicine. In the 1980s, when we'd go to a big meeting, there were many laser presentations. They thought at the time that it would even be used to cut skin instead of a scalpel. All of that did fade out over the time, but they're still fine. Lasers are still useful in medicine in many areas, particularly in, I think, optical work and so forth. So anyway, I went on to medical school, and I went on to an internship in Beth Israel Hospital in New York City, which is now unfortunately closed. This was my first chief of surgery ever, Dr. McSherry. And he, I remember very well the first day of our residency, where he said, this will be the worst year of your life. And you know what? He was right. It was the worst year of my life. I have nightmares about running up. At the time, we didn't have desktop PCs or anything like that. I had to run up to the 20th floor in the building a couple times a day to pull out the lab sheet results and bring them down. They worked you very hard at those days. They had no rules about residency hours at all. I recall falling asleep during holding retractors during one surgery. It wasn't until 1984 with a famous case called the Libby Zion case where they decided some very well-known person in New York City had a daughter who died as a result of what he thought was resident negligence and from overworked residents. So they in 1984 they passed a law to, I think it's called the Libby Zion law, to limit the amount of hours that residents could work. Anyway, I quit after that first year. And I went to New Jersey, and I worked as a surgical assistant in New Jersey at Somerset Medical Center, which was in close proximity to the university where I did my undergraduate, Rutgers University, where I had taken a computer course at one time, a coding course. And so this, at the time, I came up with what was probably my second invention, New Jersey carpool. This was a way that I thought of. I'm going to match people commuting to New York City from northern New Jersey and match them up so that they can carpool together. And so I wrote a program to do that in Fortran 4 with Watt4. This is one of the, I don't know, early computer programs. And I used Hagstrom maps. This is how we got around in those days. Nobody had a GPS. I used the coordinates from Hagstrom maps in order to input into the computer so that they used those coordinates to match the home and the destination locations. And I would then go to the key punch room, and every line of the computer code had a key punch. I would key punch the new date in, put it at the bottom of the stack, and then I would bring the whole stack again next to the computer room at the hospital, where they had the mainframe, and deliver it there. And the next day I would come and a couple of times, or occasionally, we had a match. So I would rip off the bottom of the computer printout and send it off to the clients and, accept their money. Then came along that year the gas crisis, 1979. That was the year of the Iranian Revolution and so forth, and there was a really gas crisis, and people stood on long lines to get their gas. So I thought, this was my opportunity either to put up or shut up, because people really needed the service of a carpool at that time. I didn't put up. I shut up, and we did not go ahead. But as all of you probably understand that my timing wasn't exactly right for this. Mainframes became commercial in 1952. My New Jersey carpool was from that was 1979. It wasn't only until 1983 that the IBM XT came out. Anybody here ever have an IBM XT? No, I don't think so. I don't think so. I purchased one in 1983. I had one because of a friend of mine worked for IBM, and that hard drive could contain an unbelievably high capacity, 10 megabytes. 10 megabytes of memory in it. Just for reference, this presentation is 400 megabytes. So the computer didn't have that much use. Anyway, the iPhone came out in 2007 and Uber started in 2009. So I was probably around 30 years, a little bit too early. Too early. And that's a maxim in business. Being too early is worse than being too late. Well, okay. So I decided to go back to surgery. I came here to Stony Brook, the Stony Brook University residency program. At the time, the university hospital was not built yet, and so we worked out of Northport, the VA at Northport, New York. And there I was involved in many operations, and some of them pretty ugly. And sometimes, you know, what I noticed sometimes that the surgeons be operating and there was stool all over the place. So I came up with the concept of an intraoperative cleansing of the bowel, and I developed an apparatus for that, and we wrote a paper on it. This study was done in dogs, not in human beings, thank God. But these days, I don't even know if I would do it in dogs, frankly. But that's how we did it. We got this published in Diseases of Colon and Rectum, which is the main journal for colon and rectum. Which, by the way, today I received the last printed issue of Diseases of Colon and Rectum. They're only going to be online anymore. But we showed how really clean you can cleanse the bowel. When we used an antiseptic, we found that we couldn't, even if we mashed up the bowel wall, we could not even culture anything from the bowel wall. So I think that, you know, probably the first time and only time, even until today, demonstrating how clean you can actually get the bowel with this system. Anyway, I even patented the system, and that's, I guess, when I decided that I'm going to be a colon and rectal surgeon. So I went to do a fellowship in colon and rectal surgery, and then I came back in 1989 and opened up in Patchogue, New York, the so-called Brookhaven Center for Rectal Diseases. And I didn't really give up the idea, though, of being an entrepreneur. I didn't give up the idea of maybe making use of that idea that I had. Always dreaming of something else, you know. And I thought of very hard for a name for my company. I wanted something really exotic, something really catchy. And so I came up with Tools to Serve. We incorporated in the year 2000, and I couldn't do this alone, actually. There's a lot involved as you can imagine, in establishing a medical device company. You have to write up your standard operating procedures. We used consultants, but the main engineers were Joe Zipper, who still has his name on a lot of the forms that we still use. And of course, my dad. My dad is pictured next to a guy holding a model of the Titan III rocket. The Titan III rocket was used to launch the Voyager. I don't know if you guys are familiar with the Voyager 1 and the Voyager 2, but the Voyager is still out there. It's now in interstellar space. And it's still, after 50 years, feeding back data to NASA, giving them new information about what interstellar space is all about. Next year, on November 15th, the Voyager 1 is going to hit a new milestone. It's going to be one light day away from Earth. Anyway, back to the devices that my company initially made. One of the first was this rectal sigmoid irrigator, which of course looks exactly like the device I worked on as a resident. We made a limited effort to market it, but this is Ray Kroc, the founder of McDonald's, saying the key to success is being in the right place at the right time. I don't think we were in the right place because the American surgeons, one of the uses for this device was not only to clean out the bowel, but the tumors, rectal tumors, sigmoid tumors, they shed tumor cells, and those tumor cells can implant on a newly created connection called an anastomosis and lead to local recurrence. So one of the purposes of my device was to clean out all those tumor cells in order to limit recurrent cancers. For some reason, the Americans weren't so hot on this idea, but this was an idea used very much by the English, and they used syringes and so forth to irrigate out. And if we were in England, perhaps my device would have caught on. And indeed, later on, an English company, Intermar, came up with a very similar device, essentially the same device. And this is how it works. I wonder whether the video will run.
Yes. A fluid bag is spiked and the irrigation tubing is advanced through the device. Irrigation commences when ready and can be directed anywhere within the rectal stone.
Okay, then this is another device that we developed. This is, at the time we called it anastomosis leak testers. For some reason the FDA did not like that name, so they made me change it. It's now called colorectal air syringes. This continues to be a product that we sell. Here the device is introduced. The rectum is insufflated with air. When a target pressure is reached, the pin will pop out and signal to the assistant surgeon that the target pressure has been reached. And if there is a defect in the anastomosis, you will see air bubbles come out into the pool of saline, and the surgeon will see that and know that he has a problem with his anastomosis and then have to repair it. This was and this is the only device available to give specific pressures, optimal pressures, for testing for colorectal leaks, for intraoperative testing of colorectal leaks. This is another device that we developed. This is a similar device, but this is for bariatric surgery, where the anesthesiologist uses this to inflate. And here it has a manometer attached to it, and the anesthesiologist can use it to inflate to a desired pressure, whatever the surgeon feels is appropriate, actually. And this device was copied by other devices, and these are sold all very commonly and used very commonly now. I made no move to protect the device. Maybe I should have. This is the founder of BlackBerry saying that innovation without protection is charity. Well, that's my charity, I guess. This is a device that the former interns of mine have worked on. This is the Xyron orogastric tubes. They helped me test these tubes. They helped me do the drawings and design these tubes. And they even helped me write the FDA 510K submission for the device. It was cleared by the FDA earlier this year, and we have 6 models to the device, and we've started selling it, and it's doing okay. Now, 75% of US-based medical device startups fail. And there's good reason for that. This is a very expensive business. The barriers to entry are high. The cost of doing business is very high. For example, well, it used to be that a surgeon can make a device in his garage and then bring it into the operating room and try it out. You can't do that anymore. Actually, now that all of the hospitals are part of big organizations, and they don't allow that kind of activity anymore. Any device you're going to use in the operating room has to be cleared by the FDA. So that's a barrier right then and there to innovation. The cost of a patent, as you probably know, can be very high, and it takes about 3 years in order to get the patent once you file it. Ballpark figure for an FDA clearance of any device is $30,000 to $50,000. Even every year I have to pay the FDA over $11,000 just to register my company. And if, God forbid, you're involved with any patent litigation, that can be in hundreds of thousands, sometimes in millions of dollars. How is tools for surgery able to survive? What kind of secret weapons did we have? Well, these days, actually, AI is very helpful to me. I really couldn't continue the way I'm continuing without AI. It helps me decipher what the FDA wants. It helps me write FDA submissions and all kinds of things. And I am really I use ChatGPT, and I find it very useful. But we have certain superheroes which really are responsible for making tools for surgery work. And who are these superheroes? Well, you may know them. They're Stony Brook Biomedical Engineering students. And here you have, right in front of you, 4 of those superheroes. Of course, we work commonly with the strategic partner for industrial resurgence, the SPUR organization. They help us out with funding this. And I believe they're a New York-based organization that with the mission of keeping industry in New York. Some of the activities of the interns have, through the years, included patent drawings. Of course, they're very involved in drawing our devices. I still can do mechanical drawing with T-squares, but I can't do CAD at all. So that all of that work is done by the interns. Abigail Lee was with me. I don't think she's here, but she was with me last summer. And you can see on her screen what she was working on. And this is the mold that was the result of her design. Sometimes we take field trips. The interns have gone to the real Javits Center in New York City for the MD&M East show. That's the Medical Design and Manufacturing show that they have once a year in the Javits Center. And there we look around for potential vendors for our components. And another activity, of course, is very important, is the inspections that we have to do, and also assembly. This is a very important contribution of the interns. In the last couple of years, Samantha was my main assembler. She produced most of our stock of very complex devices, and I thank her for all the work that she did for us. Along the way, the interns learn about good manufacturing practices. They learn about device medical records. They learn about travelers. They learn about inspection reports. All things you need to do to be a functioning medical device company. Every 3 years, the FDA comes by to visit me. They came back, I think it was last month they came again to inspect the company. Thank God we passed. Haven't failed yet, but it's important to abide by the practices. The interns have also worked with writing and developing the FDA submissions for the 510K submissions. That is the submission that is an application for clearance of a medical device, and they've been very involved with that. And even at least this last year, Abigail joined me at the American Society for Metabolic and Bariatric Surgeons annual meeting in Washington, where she manned the booth and sold our devices with me. This is the honor roll of all of the interns from Stony Brook that have been with me over the years. We started this in 2008 or 2010. I'm not sure which it was, but there's been 23 in all, and without them, we wouldn't have survived. Now, not everybody succeeds in this business, but some do better than others. This title photo was inspired by a race that I had in 1964 in color war. Now, granted, wasn't the caliber runner that Tom is. Tom was a New York high school champion in the mile. What year was that? 2021. But this is a color war. Give him applause. Yeah. This was a color war race that I had in 1964. I thought I won the race, but no, they gave it to this guy, Lenny Schleifer. It was close, but what happened in subsequent years wasn't really so close. There's Lenny, my sister had a crush on him, and that's me in the middle, but you all may know Lenny Schleifer. He's the founder and Chief Executive Officer of Regeneron. So although that race was close, the subsequent races were not really close. Tools for Surgery is still hobbling along toward the finish line. We're looking to be profitable. Maybe one day we'll make it. What's coming down the road? I have a few ideas that I'm pretty excited about, which I want to pursue in the next couple of years. But when they start doing robotic surgery, as far as my surgical practice, I think that's going to be time for me to retire. Thank you for listening. That's my dog Casper. I appreciate the opportunity to speak with you.
Yeah, thank you so much. All right, so as promised, I want to make sure that you guys get to ask our alumni question as well. I know some of you have to go to class soon, so do you guys mind coming to the front just so that other students can get to see your pretty faces, your superhero cape? Yeah, so I'm going to just let you pass the microphone. If you guys can talk about when during your academic time that you actually did this internship with Dr. Lebov, and just like brief description about what you did, like just briefly, and then students get to ask you guys question first before you have to go to class. And so I'm going to start with.
So hi, I'm Samantha, and I worked there starting from the summer of my sophomore year, and then I continued until like I worked during my junior and senior years too. And then I worked more on the manufacturing side, and I felt like I got to do a little bit of everything. I did manufacturing, I did some of the drawings, and I also did some of the paperwork as well.
Hi, I'm Sana. I actually worked last summer and last fall at this internship, and I worked mainly on the AutoCAD designs. I kind of piggybacked off of what was already existing, and then Dr. Lieboff wanted a newer design, like a potential design, so, which I'm not going to specifically
You
talk.
can,
Okay.
it's okay.
Okay.
You can talk about it.
It worked with like LED lights within, you saw before, like the orogastric tubes. And yeah, so I worked mostly on the AutoCAD designs, and then we also were working on 510K, so I assisted in that, and then I did a lot of testing as well.
Yeah, and when she says she worked on pre-existing designs, I think like I helped with the pre-existing designs. Yeah, like we sign our names at the bottom. She's probably like erasing my name and putting her name. Yeah, I was mainly working with AutoCAD, working on the Xyron, SGT, and OGT, or gastric tube for bariatric surgery. Yeah.
Very
It was
good.
really fun.
Very
Yeah,
good.
worked on some 510K stuff, some experiments actually in the actual company. We had to, take measurements of the actual surgical device to actually submit them to the FDA too. And yeah, I worked there for the summer, and then I worked part-time when I was here for my junior year too, so it was good.
Hi, I'm Jacob. I started working at Tools for Surgery last summer and continued into this spring. I was working mainly on the tool, the anastomosis leak tester that you previously saw on the screen. Like they said, part of that, I was also hopping around helping everyone out there, doing pretty much a little bit of everything along with that.
Yeah, thank you for sharing. So, because we will have to run soon, so I want to open up for question right away. So, Moise, do you want to start with a question? Yeah, I was thinking. He's good at asking.
What is something you guys used in your BME education career that helped you a lot to succeed in your job or internship at Tools for Surgery?
I think BME 203 really helped. Yeah, because a huge part of this was AutoCAD, and I used a lot of that knowledge within this company. Yeah, it was just like a large part of it.
Another question?
What was your favorite project that you worked on? Like, what was the most impactful one that you worked on, and why?
I mean, we all had our own project designated.
Go down the line. Each one.
You want to hear from everyone?
Oh, sorry. Okay.
I mean, my main project I worked on the whole time was the anastomosis leak tester. Other than that, I did testing with like the Xyron tubes. I did some of the manufacturing for it, but really the anastomosis leak tester.
Well, a new innovation of it, not exactly,
Yeah, a new
not
rendition of
exactly
it,
what
yeah.
you saw on the screen.
Yeah, it was a new version of it.
Yeah, and then like I mainly worked on the Xyron. We were trying to like update it too, so I guess it was a new rendition. And
Right.
we were trying to make it one body, like one more complete body. I remember, like make it a little more simpler.
Yes, that's correct. Yes,
Yeah.
correct.
And it was cool too, because I did sometimes contact the manufacturers in where are they, in Afghanistan? Pakistan, yeah. So that was cool. So I got like to see on the manufacturing side, like how to communicate with those people too.
Oh, what I worked on? Well, I was saying it earlier, but I also worked on like a newer rendition of the orogastric tube, as I mentioned before, with the LED lights. And yeah, it was cool to work off of what was already existing and incorporate a newer design within it, which it also kind of made it easier because we already had existing drawings. So yeah.
So I worked mainly with the manufacturing, and then one of the main projects that I had was kind of how to make the manufacturing process more efficient and how to like make some steps, make them less difficult to do and make it faster to manufacture. So that was kind of my project.
And she did a very good job at that, yeah.
Another question?
Ask another one.
I'll ask first then.
Yeah.
I'll skip you. So you guys mentioned that you work during the summer or during the semester. Do you have any like special way to make sure that your schedule works out okay? Because I think in summer you might be doing it more like a full time. During the semester, you are not taking the semester off, right? So you're still taking classes and doing this at the same time. How do you manage the time for doing that?
So Dr. Leboff was actually pretty flexible with our scheduling, so we basically would just tell him in the beginning of the week or the week before what time we would come in, and I think I did like 8-9 hours a week, so it wasn't too bad.
Yeah. Oh, okay. Good. All right. Good. Yeah. Any more question for the student before they run away? Yeah.
What's like some advice or tips you would give to us in BME 100 since we're all starting out and we're new to this? And you talked about 2 or 3 really helping you, but some of us haven't taken that class yet. So what are your advice on how to get started into internships, tools for surgery, and looking for opportunities like that? Or what skill sets we should have?
Okay. I mean, you have to put yourself out there. The way I found this was through actual Stony Brook. Like, they send you out emails and stuff. Like, make sure you're on top of that. Stony Brook gives you some great opportunities, but, they're not going to just, like, hand it to you. You got to, like, be on the lookout for them, check your emails, and also, like, apply to internships. You're learning stuff in class, but that's not experience. You have to actually, like, go out and get the experience, because it's quite different what we do for a job, because you gotta like, this helps you, but there's like another level to it, Hopefully that answers your question.
Because it's not theoretical anymore. It's actually real products.
For me personally, I went into working at Tools for Surgery with very little experience outside of the classroom. I'd say best advice, just like Thomas said, throw yourself out there, apply to it. Worst that happens is they could say no, but it's the only way you're going to get it. So just throw yourself out there. Don't be afraid to.
Yeah. One more question. I think they really do have to go. So any more questions for the student? Yeah, thank you so much. So our student asked if you guys want a picture, you can go. Yeah, always ask. Yeah, right? All right, so we're gonna continue with Q&A with now solo, like Dr. Leboff again. So anyone want to ask a question about the things that you have here from the presentation? Yeah, there's anybody. Yeah, Moise has a question. Yeah, go ahead.
So we talked about like how you invented certain devices, but do you feel like we will ever implement AI, or like you will ever implement AI in your devices to help, with surgeons?
Yeah, that's a good question. Do I can still have control of my slides?
Yes.
That's one of the things that I was actually going to mention. Is how AI is going to influence what you guys do. AI is going to have a massive influence on what you guys do. I know that what I showed you in terms of my mechanical drawing looked pretty primitive to you. What you're doing today and what the interns do for me in about 10 years or so is going to look pretty damn primitive to the interns coming along 10 years from now. These drawings here, these drawings were not done with my mechanical drawing tools. These drawings were simply done by ChatGPT. ChatGPT is not a program that's particularly good at CAD drawings, but I assure you, out there this very day, programs are being developed where an inventor will simply verbally speak to the program and tell him to draw exactly what he wants. That's coming along. And probably in 10 or 20 years from now, I'm not going to have a need for an intern to come and do my CAD drawings. I'm just going to speak to the program. So yeah, AI, massive influence in everything.
Question? Oh, yeah, there's a question.
You seem very enthusiastic about your work, and I'd like you to speak a little bit about your motivation. What is it that keeps you going and developing and thinking and et cetera?
My motivation? I'm going to Mary Jo, I'm going to disappoint you. I'm going to disappoint you a lot. Just let me get to the slide, because you want me to talk about my motivation. Oh, that's pretty sad. Actually, I do have an interest in doing this stuff. I do kind of enjoy it. It keeps me busy, and I obviously like the idea of innovation. And you got to really find something that you have some interest and passion to do if you're going to spend the rest of your life doing it. I'm fortunate that I'm able to keep up my medical practice by limiting myself to what I do right now. And also, this keeps me occupied as well. It keeps me out of trouble, and I kind of like it. I kind of enjoy it. And I hope all of you are able to find similar passion in your lives.
And I'm guessing from what you're saying that as you go along and try to do this, you're learning a lot of stuff and you're having to keep abreast of a lot of things. Is that part of what keeps you going, and is that really a positive reinforcement for you?
I am learning a lot of new stuff every day, and I'm surprised how much social media gives me in terms of history and new information. I'm amazed about how much information I have at my fingertips, and you guys are in a whole different world than when we used to be. The amount of information is immediate access to you is phenomenal. So yeah, it's different, and I guess that motivates you as well.
All right, I'll leave you alone now.
Yeah, another question from Sue.
You said about like AI, like many of the designers might get replaced by AI. So like.
Well, I didn't exactly say that. I was speaking about the activity of CAD drawing specifically. You always need the human element for the innovation, for the ideas. That's not going to go away entirely. But there will be massive changes coming, even to my field of surgery. In 10, 20 years from now, there's going to be autonomous surgeons. The surgeons will insert the instruments perhaps at bedside, but then they'll leave it to the robots to go ahead and dissect out the gallbladder, divide the vessels. The robots will do that autonomously. That's coming. And you're going to need engineers to develop that capability. And then you're going to use AI as tools to help you develop that capability. So there's a lot of work coming out for you guys. It's just that some of the tools that you work with now will be anachronistic years from 10 years, 15 years from now. Yeah.
Another question? I want to ask a question actually. So yeah, thanks so much for your presentation. It allowed me to understand more your journey, how you go from a little kid who did not dream about this until the point that you are actually creating it for real without the help of your father anymore, right? So that's important. And I think when you were describing how you have a clinical observation that because you are a surgeon yourself, so you get to see what type of things are actually needed. So in our BME 100 course, we tell students that most biomedical engineers don't just do something for the sake of doing it, because they actually see a unmet clinical need, right? And you need a new invention for that. The part that I would like to hear more about is, once students have an invention, I think there are a lot of challenges along the way, which you described a little bit, such as FDA regulation, and even like the supplier, right? Because I think a lot of time, students nowadays get really good at 3D printing, but then 3D printing is not exactly the material you will end up using. And then a lot of students then, like, they're stuck, you know, like they were like, oh, what should we do next in terms of actually manufacturing it, picking the right biocompatible material, sterile material, you know, things like that. Would you be able to share a little bit more how you are able to learn all these things while you're so busy with like other things in your life? Because it's a lot, right? Like trying to figure out all
There's
this.
a lot, sourcing out manufacturers for your components, for example. How do you do that?
Yeah.
How I did it, I showed you, for example, MD and M East at the Javits Center. I used to go there and just walk around and look for vendors, talk to them, and see who could make my devices. So often I found vendors offshore. I have vendors from China, from Pakistan, from northern New Hampshire, which might as well be offshore. So yeah, that's one thing you have to do in order to in order to end up building your devices, because some things you just can't do in this country. They're just too expensive. And you'd be surprised at the price differences for the different components that you get between estimates for United States manufacturers and, for example, manufacturers in China. That may all change by the time you're ready. Who knows? China may be more expensive in 10 years to do the way we're going. It might be to do stuff. But for now, you got to go. You got to get out there and you got to look. But these days they have other ways to doing. You can actually there are websites you can go on to have your to have bids for your prototypes made. I haven't used such a website because I have somebody in Pakistan who does my metal work very cheaply. But there are ways to find manufacturers, vendors for even if you have a simple idea you want to pursue.
Yeah. Any question from the student? Don't be scared. You can ask a question. Even though he's not an alumni, he likes you guys. You can ask a question. I'm not pick people's name. I always like to do that. Shadi, do you want to ask a question?
Honestly, I can't think of anything. Every question I wanted to ask has already been asked by
Okay. That's a good way to say you're not asking a question. Let me see, I'll pick someone else. Is Ian here? Do you want to ask a question?
I wasn't able to hear much of the...
You came in a little later. Yeah, that's fine. Yeah.
What qualities do you look for in your interns?
Oh boy! Oh boy! I like, to be honest with you, I like to see a successful academic career. I do look for that, and I do like to see some enthusiasm. I don't mind if someone bothers me, if somebody pesters me about a job. I don't always give the job to such a person, but if you really want to work for Tools for Surgery, don't be shy about doing that.
All right. Yeah. Any more questions? Stop pestering. Any question?
there's a lot of engineering that's going to be going on for the next few years. I hope some of you get into the medical or surgical aspect of it. But I caution you that if you do, you have to partner up with the surgeons, with those who are actually performing the activities. I showed you a picture of Joe Zipper, who started my company with me. He was great. He did a wonderful job. But there were times when he had ideas that really, as a surgeon, I didn't think would make it. And I have to caution you to work very closely with those who are actually doing the activities. And don't go astray, because you can do an awful lot of work that won't come to anything if you are misled by your own imagination.
So you talked about how the engineering field will be affected. How do you think the surgical field will be affected like 10 years or more?
Well, I touched on that before. I talked about autonomous surgery. That is certainly coming. I showed you a picture of a robot doing a hemorrhoidectomy, which is the greatest fear of my life. I don't think that's going to happen, actually. Certainly not in my lifetime. There are some jobs, there are some activities that a robot will, well, you can't say never. You can't say never. But probably won't substitute for. But come on, you see how fast AI is developing. And that in 10 years, ChatGPT is going to look primitive as to what its capabilities are now. You know, I'm sure you've all experienced AI. I'm sure you know exactly how you have to check everything AI. Never submit anything without reviewing it by AI. Never reviewing it yourself. That's a big mistake, because AI confabulates, it hallucinates. I asked AI, to find me a patent that said a certain thing. I needed it to say a certain thing, something in the past, and lo and behold, it found that patent. And instead of submitting that patent to my lawyer, I looked up that patent myself. It had nothing to do with what it said. So nowadays you have to be careful. But in 10 or 20 years from now, the AI program is going to be auto-correcting all the time, and they're going to be a lot quicker, sophisticated than they are now, and you won't have this big problem of hallucination and confabulation. But that's coming along, but not now. When you write out your reports, and you all must do this now. And my interns have, my interns are gone now, but I still have the ability to see an AI product when I come across it, and I know they've used it even when they've written some of their reports. Some of them have gotten credit, academic credit, for the work that they did at Tools for Surgery. They got, some of them I think got paid and academic credit at the same time. I think that's cheating a little bit. I don't know.
They separate the time.
Did they?
Yeah, I make sure.
No, you make sure.
Yeah, I make sure.
Okay, good. But yeah, be careful how you use it.
Oh, one more question, yes.
So, would you trust a resident or an AI to do surgery? Do you think the answer to that question would change in like a few years?
Well, robots are not doing, for example, robots are, of course, used in abdominal surgery routinely now. It wasn't the case 10 years ago, no. And in fact, one of the reasons why I stopped doing general surgery, one of the reasons that I stopped doing abdominal surgery is because I had to make a choice, either learn the robot or stop practicing colectomies, for example. And so I felt I was just too late in my career to go into learning the robot. I had too much to do, so I stopped doing abdominal surgery. So robots are being used already, of course, but that's when I was speaking before about autonomous robotic surgery, I was talking about something else. Robots are used now as tools to coordinate and to, when the surgeons manipulates a remote control device, that device is taking place within the body cavity. But it's the surgeon who is remotely doing the surgery. That's going on now. In 15 years from now, in 20 years from now, the robot is going to be doing the actual surgery. The robot is going to be identified where the gallbladder is, where the common duct is, where the artery is, sever the artery by itself, sever the common clip and sever the common duct itself. It's going to be doing that by itself. The surgeon will be there for medical legal reasons, yes. Okay, he'll be at the table, he'll be at the platform, off the table, but the robot will be doing a lot of the work itself. In my type of work, the fissure work, the fistula work, the hemorrhoid work, that's a little bit different. It's not as conducive for a robot to do that. So in some areas, the robot will take more control than in other areas in surgery.
Yeah, this is actually a really good discussion because in BME, actually, there are some research being done right now that most of the robotic surgery, they are using tools that cannot feel. They are basically like what you're saying. The surgeons are still the one controlling them. If you want to do minimally invasive surgery, you're still having a surgeon to be the one who control it. But because when you touch the thing, unlike a surgeon actually doing the surgery, you will feel resistance when you cut into things, right? Right now, most robot cannot do that. So a lot of research are being done to add sensor to the robot so that they can start feeling. So yeah, so as Dr. Leibov said, maybe many years later, when the machine get better, maybe they can do it by themselves. But like as of now, not yet.
It's coming. Yeah. It's coming. AI will through the use of tools we're not even using routinely today, like injecting certain dyes through the system. The AI program will identify where the gallbladder is, will identify where the common duct is, and will autonomously be able to dissect and divide and operate on the structures without the surgeon actually manipulating the arms and components of the system.
Yeah. Any more questions from the student? Yeah.
I wanted to ask more about how do you balance working as a surgeon and working on your business?
How do I balance that?
Ask the wife.
Look, what takes up most of my time these days is taking my dogs for walks. I have stepped back a little bit. In my practice, I am now a part-time surgeon, and that helps me devote more time to tools for surgery. Tools for surgery was started in the year 2000. Sure, we progressed some, but we're not a huge company, And so, as you can imagine, I couldn't devote that much time to it over the years. But what time I could on the side, I did, and we were able to develop some products and come along. Now I'm a little bit more involved, a little bit more anxious to move it along a little faster.
Yeah, go ahead.
has your definition of human control changed over the years?
Do you want him to elaborate?
Yeah, why don't you
Yeah, can
elaborate? Make
your
it easier
question?
for me.
If you think that, like, because now that you're kind of forced to change your ways, like, you know, instead of like trying to learn AI, you're like taking time away from your practice. Do you feel like because of that, like do you feel like you're losing control, or has your definition of control changed?
Well, I think your premise is wrong, that I have to learn AI and it's taking away from my other activities. AI makes things so much easier for me, makes things so much faster for me. Every day I tell my wife, who hates AI, she thinks it's somehow competing with her or something, I don't know. She thinks it's stupid because it does give wrong answers sometimes, and it's given her some wrong answers. But I am every day, and I tell her that, impressed with the amount of information I can get so quickly. So no, it's done the opposite. It's made me move along much faster, and it's allowed me to maintain the business. Without AI, at this point, I probably would not be in business anymore. Okay, because I can do so much now myself, because I have consultants looking over my shoulder all the time. And that's, in my case, ChatGPT.
And yeah, I actually agree with it like a lot. You're using that as a tool, and as you mentioned, you don't trust it 100%. Also, you also need to double check what it gives you, right? And sometimes it is wrong. So we're using it as a tool, just like in the past we used Google search, and we try to use keyword, right, to look for answer. But you have to check, like, if they're giving you the right thing, right? Even the patent that you talk about may actually is not the one you're looking for.
Yeah, a couple of months ago, there was a New York Times article about lawyers using AI and lawyers submitting their product done by AI and how they got in a lot of trouble of that, perhaps disbarred also from doing it. You got to be very careful with that. You got to always, again, we just said this many times, you got to always review the results, what AI is giving you. But that doesn't take away from the fact that it is an enormously helpful tool.
Yeah. Any more questions? Yeah, okay, I think this is the last question. I don't want to keep you longer than we asked you to be here.
Yeah, what are like your thoughts on the ethical considerations with regards to robotic surgery? Because some people don't even like AI, like for ChatGPT. How would they feel having their surgeon as a robot? How would they feel? What are your thoughts on that?
I'll tell you what my thoughts are. Okay? Some people would never get into a Waymo. You know what? Raise your hand if you know what a Waymo is. I see about half the people know what a Waymo is. Some people will never get into a Waymo. Of course, it's the autonomous vehicles that are being used routinely out in California. Some people would never get into a Waymo. They'd be horrified. I have a Facebook post where I'm sitting. I am sitting in the passenger seat, and I have a little video of nobody in the driver's seat, and the car is going. And some of the reactions from my friends on Facebook was they were horrified. And yet my daughter loves Waymo. She doesn't have to speak to the driver. She uses it all the time, too much. She should walk more, I guess. But it's the same thing. Now, Waymo, the Google, who owns Waymo, I think, or Alphabet, which owns Waymo, just put out a study on the relative safety of Waymo, and it reduced accidents more than 90% of the time. Okay? So eventually, we should all be using Waymo. Well, we should not, we won't always, there'll always be those who will demand that they can drive the car. That's always going to be. But for safety's sake, we should develop into a society where all cars are autonomous. because the amount of accidents and lives saved, the amount of accidents will be dramatically reduced, and the lives saved would be incredibly increased in that world. That's going to be the same thing in the surgical world. People are going to be horrified, and some people will be horrified at the thought that a robot is going to take out their gallbladder. But years beyond that, people are going to be horrified to let an actual surgeon operate on them.
All right. Yeah. So let's thank our speaker. Yeah, thank you so much.
Thank you.
I really enjoyed it. Yeah, thank you.